Hello everyone, this is your YourTutorAB and today we're going to be looking at the question 1 of the May 2019 IB Physics SL examination. This comes from the paper 2. This question deals with projectile motion and includes sections of momentum and impulse, kinetic energy, work and power. So let's solve this question together. A student strikes a tennis ball that is initially at rest so that it leaves the racket at a speed of 64 meters per second. The ball has a mass of 0.058 kilograms and the contact between the ball and the racket lasts for 25 milliseconds. The student strikes the ball at point P. The tennis ball is initially directed at an angle of 7 degrees to the horizontal. And here we can see a diagram. It's not drawn to scale. And they've given us the following data. The height of P is 2.8 meters, so it's being struck 2.8 meters from above the ground. The distance of the student from the net is 11.9 meters. The height of the net is 0.910 meters, and the initial speed of the tennis ball, as given before, is 64 meters per second. So let's look at part A, worth 2 marks. Calculate the average force exerted by the racket on the ball. Okay, so to do this question, we want to use momentum and impulse for solving the question. So how do we do this? Let's recall, what is the formula for impulse? J is equal to average force into time. But impulse can also be written as the change in momentum. So we can say delta momentum is equal to average force into time, into the change in time. And of course, we know the formula for momentum is P is equal to mass into velocity. We are given the mass, the M is equal to, according to this question, M is equal to 0.058 kg, so we can say 0.058 kg, and the velocity is, of course, they've said is 64 meters per second. Using this, let's solve for the final and initial momentum. So we can say P1 is equal to 0.058 mass into velocity 64. P2 is equal to 0.058. This is actually the initial, so let me rewrite this, make it more clear what I'm trying to do. Let's go back. This is P final, this is P initial, and the velocity, as it says the ball was initially at rest, is 0. So when we solve this, we get P final minus P initial, which is also the same as saying, let's put this into our calculator, 0.058 into 64, you get 3.712 minus 0, so that's the initial momentum. And so we can put this back into our formula. So we want to rearrange our impulse formula to solve for F. So let's rearrange in terms of F. So average force is equal to the change in momentum by the change in time. So we can get force is equal to 3.712 divided by time is 25 milliseconds, if I'm correct. 25 milliseconds is actually just saying 0.025 seconds. We always need to have it in seconds. And so when we divide them, we get 3.712 divided by 0.025. You get 148.5 newtons, which is approximately 150 newtons, and that's your average force exerted by the racket on the ball. A2. Calculate the average power delivered to the ball during the impact. And this is another 2 marks. So let's recall, what's the formula for power? Capital P, power, is equal to the work done by the change in time. And there's a specific theorem which we can use to find out the work. It's called the work kinetic energy theorem, where work is actually equal to the change in kinetic energy. So K final, kinetic energy final, minus kinetic energy initial. So let's find out the two kinetic energy, and with this we can find the work done for this formula. So the formula for kinetic energy, as you know, is just half mv squared. So let's find out the kinetic energy final, which would be half times the mass. The mass we know is the mass of the ball, we know is 0.058 kg, 0.058 kg into 64 square, as that's the velocity, 64 square. The kinetic energy initial is half, again the mass is the same, 0.58, into, if the ball was initially at rest, so 0 square, so that just equals to 0. So what does the kinetic energy final equal to? Let's put this into our calculator. So we get 0.058 divided by 2 multiplied into 64 square. We get about 118.784 joules. So we can just subtract these two. We know that final minus initial would just be this number. So the change in kinetic energy is work is equal to the change in kinetic energy, which is just 118.784 joules. And let's put this into our formula from earlier. Power is equal to work over change in time. So we can put this in there. So power is equal to 118.784 divided by the time was 25 milliseconds. So this becomes 0.025 seconds. And when we divide this and put this in our calculator, we get 118.784 divided by 0.025, and you get something about 4,751 watts. That's the unit for power, watts. And that's your final answer. So B1, calculate the time it takes the tennis ball to reach the net. To solve this question, we have to use the principles of projectile motion. So let's take a look at this diagram they've given us from earlier. Here, we can see that there is a right-angled triangle being formed. The hypotenuse is represented by the speed of the racket, speed of the ball after it's been hit by the racket, 64 meters per second, and they've given us an angle to the horizontal, which is 7 degrees. This 64 meters per second can be broken down into the components of velocity, a horizontal and a vertical. So let's resolve this velocity to find the x and the y velocities. Using the x, we will be able to find the time. So let's draw the right angle triangle. It should look something like this. So they said there was 7 degrees to the horizontal, and we know that the ball travels at a speed of 64 meters per second after it's been hit by the racket. This 64 meters per second comes from the horizontal and the vertical speed. So let's find the horizontal component of this velocity. So we need to find the adjacent side to this right angle triangle. How do we do this? Every time we hear adjacent, it automatically means cosine. So cosine of 7 is equal to the adjacent side over the hypotenuse. Now rearranging, we get 64 multiplied into the cosine of 7 should give us our horizontal velocity. So let's put this into our calculator. We get something along the lines of x is equal to 63.52 meters per second, and that is our horizontal velocity. Now we may need a vertical velocity in the future, so let's also solve that, but that is not necessary for this question. That would be y. So to find the y, we need the opposite side. Opposite side means sine. So we can say sine of 7 is equal to y over 64. We solve this. 64 multiplied into sine of 7 gives us the vertical velocity. So the vertical velocity is equal to 64 into the sine of 7, 7.8 meters per second. Now this is for future, so let's leave the vertical velocity. Let's look at the horizontal velocity. What is asking us to find? Time. Now note, for every projectile motion question, the horizontal component of velocity is always constant, so we can directly use the formula t is equal to distance over speed v. So we can put this into the equation. Time is equal to the distance, which was given earlier, 11.9. So we can put 11.9 over our speed, which we got 63.52, and so we should get the time it takes to reach to be something. Let's put this into our calculator. 11.9 divided by 63.52, we get the time is equal to 0.187, which is approximately 0.19 seconds, and that is our answer for this question. B2, show that the tennis ball passes over the net. This question is worth 3 marks. Okay, so to solve this question, we need to use the kinematic equations, and we need to preferably find displacement. So how would we find displacement? We have the main equation, which I feel is best for this question, which is S is equal to ut plus half A.T. squared. Now we have all the necessary variables for this question. We have the initial velocity, which is the vertical component of velocity, which we calculated earlier. We have time, which we got from the previous question, and we have acceleration due to gravity, which of course we know is negative 9.81 meters per second squared. So let's sub all this into the equation. S is equal to the horizontal vertical component of velocity 7.8 multiplied into the time, which we got last question as 0.19 plus half negative 10. Let's use negative 10, it's easier, and t squared 0.19 square. So let's put this into our calculator. So we get displacement is equal to, so 7.8 into 0.19. This portion is equal to 1.482 plus negative 5 multiplied into 0.19 square. That gives us so we get 1.482 minus 0.1805. So we get the displacement is equal to, let's minus these two together, 1.30 meters. Now let's take a look at the height of the net. The height of the net is 0.910 meters. What is the height that we found the ball is at this exact instant is 1.30 meters. So as 1.30 meters is greater than 0.9 meters, the ball passes over the net. So that's the solution to this problem. B3. Determine the speed of the tennis ball as it strikes the ground, and this is for 2 marks. So let's solve this question. How do we do it? Let's draw a diagram from earlier, a right angle triangle. We know the horizontal component of velocity, which is 63.52. We calculated this earlier, and we know in projectile motion, horizontal velocity always stays constant. Then our resultant velocity is this hypotenuse, which is what we want to find. And then finally, we have our vertical velocity, which does not stay constant throughout motion, which is what we want to calculate in order to use Pythagoras theorem and then calculate resultant velocity. So it's called that y. So how do we calculate this final vertical velocity? Well, we have to use one of our timeless kinematic equations. This timeless kinematic equation we can use is v square, which is just our y square, is equal to u square plus 2as. We have all the variables for this equation, so let's directly put them in. V square is equal to u square, which is just negative 7.8 whole square. We calculated this earlier. This was the initial vertical velocity, plus 2 into acceleration due to gravity is negative 10, into the displacement from the top to the bottom, which was given in the question to be negative 2.8 meters. Now, putting this all under a square root, we get the answer negative 7.8 square plus 2 into negative 10 into negative 2.8. We get the final vertical velocity is equal to 10.81 meters per second. So using this, let's resolve this velocities to find our resultant velocity. Let's go back. We now know what is this final vertical velocity, so let's substitute that in. 10.81 meters per second. Now using our Pythagoras theorem, a square plus b square is equal to c square, we can get our hypotenuse, which is our resultant velocity, which is what we want to find for this question. So c is equal to the root of a square plus b square. So let's put in our values that we know. C is equal to the root of 63.52 whole square, and that becomes plus negative 10.8 square. Now when we put that into our calculator, we get the answer to be 64.4 meters per second. If I have double check, yes, the answer is 64.41 meters per second, and that is our speed of the tennis ball as it strikes the ground.